Hello and welcome back to problem set 3 in mensuration. In this problem set, we will deal with problems based on Euler's formula. So let's begin with a very simple problem that is a direct application of Euler's formula. If for a polyhedron f is equal to 12, v is equal to 20, find E. I hope you remember f is the faces, v is vertices and E is the edges. So we simply write our Euler's formula f plus v equals E plus 2 and we plug in the values of f and v. Therefore 12 plus 20 equals E plus 2. Therefore E will equal to 12 plus 20 minus 2 and that is equal to 30. And we have solved our problem. We have found the number of edges E is equal to 30. Now there are only two things that you need to remember to solve problems in this section on Euler's formula. One is Euler's formula itself. The second thing is the concept of prisms and pyramids. So let's take a look. Now for prisms and pyramids, both of them are polyhedrons, meaning they have all straight edges. But the difference lies in their vertical faces. So for prisms, you have all the vertical faces are rectangles, whereas for pyramids, you have all the vertical faces are triangles. Now this is quite easy to remember because if you've seen pyramids, for example, the Egyptian pyramids, you know that they are all triangles. So the vertical faces are triangles. So let's look at what these polyhedrons actually look like. This would be an example of a prism because you have a rectangular base and you have all the vertical faces are rectangles. Whereas this would be an example of a pyramid. Again, you have this rectangular base, but now all the vertical faces are triangles. So the point is, you don't care what the base is. The base can be a rectangle, triangle, hexagon, square, whatever. But you care about what the vertical faces are. If they are rectangles, it is a prism. If they are triangles, it is a pyramid. Now the idea of these problems is that the number of vertical faces for each of these solids. In the case of prisms, you have one face at the top and you have one face at the bottom, which is the base of the prism. So the number of vertical faces will be the total number of faces minus these two faces. Whereas for a pyramid, you have only one face at the bottom, this base, but you have nothing at the top because all these sides meet at one single point. So for a pyramid, the number of vertical faces will be the total number of faces minus 1. I repeat, for a prism, the number of vertical faces is f minus 2. For a pyramid, the number of vertical faces is f minus 1. Now in your examination, they might either ask you to find the number of vertical faces or they might ask you in another way to find the number of edges of the base. Notice that these are the same thing. The number of vertical faces is the same thing as the number of edges of the base. So with this in mind, let's solve our next problem. In our previous problem, we were asked to find E for a polyhedron given f is equal to 12 and v is equal to 20. Now we have a follow-on to this question. We are asked if the polyhedron is a prism, find the number of edges of the base. So if the polyhedron is a prism, what did I say about the total number of vertical faces? They are going to be f minus 2. So we can write a prism has one face at the top and one face at the base. Therefore, the number of vertical faces is equal to f minus 2. And since we know that f is 12, we are given f is 12, we can find out that the number of vertical faces is equal to 12 minus 2 equal to 10. Now remember what I said, the number of vertical faces is the same thing as the number of edges of the base. So we can say therefore edges of the base is equal to number of vertical faces is equal to 10. And we have solved our problem. So with this we come to the end of this problem set on Euler's formula. Thank you for watching and see you in the next video.